So let's take a look at the TCA cycle, or you may have heard of it referred to as the Krebs cycle or the citric acid cycle. This occurs all within the mitochondria, and basically what it is we are further processing the pyruvate. Previously we talked about how pyruvate ends up as acetyl-CoA. Acetyl-CoA enters the cycle right around here. And what we're talking about now is this process is valuable in both the metabolism of lipids or fats and the glucose that has gone through glycolysis. So, here we go. We bring in the acetyl, make it into acetyl-CoA. Acetyl-CoA goes around into citrate. Remember I said this is called the citric acid cycle. Isocitrate is formed, and when this happens, we're actually producing another NADH. Now remember, several electrons are removed now, forming NADH, and so we're going to get 3 ATP. After isocitrate, we get another NADH, 3 more ATP. This process just keeps going, and along the way, various processes produce more energy. We get to a point here where we produce a new compound, FADH. FADH is a little bit different, but FADH, flavin adenine dinucleotide, produces 2 ATP. So NADH produces 3, FADH produces 2. We continue around this cycle until the point in which what we can see now is that we've produced a number of ATP. We end up producing ATP all around this cycle. We produce an initial 3 ATP when we change pyruvate to acetyl, come around the cycle, and then we produce 3 more NADHs, here, here, and here. Each of those you can see is responsible for producing 3 ATP. Down here, we end up producing GTP, guananosine triphosphate. That's not important. What's important is we produce another ATP. And over here, FADH produces 2 ATP. So I'm not going to ask you to memorize all of these individual steps. What you will have to know is how many ATP does each cycle produce. If you quickly add these up, this cycle produces 15 ATP, 3 from the conversion of pyruvate to acetyl, and 12 along the cycle itself, 3, 6, 9, 10, 11, 12, 15. Now remember, each glucose produces 2 pyruvates. Both pyruvates create their own or enter into their own TCA cycles. Therefore, 1 glucose produces 30 ATP through the TCA cycle. Remember that through glycolysis, we produced 8 ATP. You can see how this aerobic metabolic system is a much greater generator of ATP for longer activity. So, when we look at the processing of glucose combined with an oxygen supply, we need oxygen in order to get into the oxidative metabolism. Glucose plus oxygen allows us to produce 38 total ATP. 8 from anaerobic glycolysis, 30 from oxidative glycolysis.